Hey guys, so today we're looking at Algebra 3's 2.3, and this lesson is very much review, alright? So we're looking at finding slope given 2 points, that's like y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm just going over a lot of this briefly so that if you think you know how to do most of it, you can skip ahead. And if not, then I'll explain it, and that's totally fine. So the second is graphing using slope and y-intercept. So that's graphing in slope-intercept form, where m is your slope and b is your y-intercept, and you just plot this and graph the slope based on that. Then use information to write an equation in slope-intercept form. So that could be like given a single point and the slope, and you write an equation in slope-intercept form. And then finding and using intercepts to graph an equation in standard form. So finding intercepts is like to find an x-intercept, you plug in 0 for y. To find a y-intercept, you plug in 0 for x. You plot the 2 points and you graph. If all of that was over your head, then that's fine. That's what this lesson is for, is to teach you how to do that. So let's move on. So find a slope given 2 points. Say your 2 points are x1, y1, and x2 and y2, where your first point is labeled 1, and it's the x and the y's, and the second point is labeled 2, and it's the x and the y's. The slope formula is the difference in y's over the difference in x's. So it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So find the slope of the line that passes through these 2 points. So you just want to use your formula. So you've got x sub 1, y sub 1, x sub 2, y sub 2. And it's the difference in the y's, so negative 1 minus negative 1, over the difference in the x's, 2 minus 9. And it's really important that you do it in the same order. If you do this ordered pair first, it needs to be first on the top and first on the bottom. This is going to be negative 1 plus 1 over negative 7, which is 0 over negative 7. And that is 0. So your slope, which has a variable of m typically, is 0. All right, now moving on. How to graph things in slope-intercept form. All right, the slope-intercept form is y equals some number times x and then some number. It's not necessarily a plus all the time. Sometimes it's a minus sign like it is here, but it's always some number. So here we have y equals 5/2 x minus 6. So the first thing you want to do is plot the y-intercept. This number here is the y-intercept. This is the value of y that your graph touches on the y-axis, which is negative 6. So you would go down to negative 6, 1, 2, 3, 4, 5, 6, and plot a point. Right? This is your y-intercept. Then you, in the next step, I don't think I want to use that blue. I think I want to use it darker. The next step is to move based on your slope from that point, from the y-intercept. So it is 5 over 2, and slope is rise over run. So the top number is how far up or down you'd go, and it's a positive 5, so you go up 5. And the 2 down here is how far left and right you go, and since it's positive, you move to the right. So you'd go up 5 and right 2 from this point. So up 5, 1, 2, 3, 4, 5, and right 2, and that's what you've got. And you have a line that connects these 2 points. And there you have it. That is your line. This form is really convenient because you don't have to do any work. If you have a coordinate plane, you don't have to manipulate any equations. You just look at it with your eyes, plot one point, and then do one thing. Next idea, find the equation of the line that passes through 5, 3, and has a slope of 1. So this is the first of several different problem types that revolve around writing an equation of a line. And the way we want to write it, there is a form called point slope form that would generate an equation instantly, but that's just one more thing for you to memorize. And while it would make a problem like this more convenient, I think that it in general makes students memorize more than they have to. So I'm going to fall back on our knowledge of slope-intercept form to find an equation in slope-intercept form. So if you look back up to the previous example, this is an equation of a line. And I want to point out two things that it has. This equation has the letter y and the letter x in it, okay? So your equation of your line will also have a y and an x in it. So when you get to your answer, if you don't have a y and an x, you've done something wrong. You might have just like x equals something or y equals something. If it doesn't have both variables, you're doing something wrong. So the reason I bring that up is because of what we'll have to do here. We know that m is slope, so this is slope, so m equals 1. And this 3 is not necessarily your y-intercept. It's only the y-intercept if the x value is 0. But the x value is not 0, it's 5. So if you were to plot 5, 3, I'm just coming up here to show you. If you were to plot 5, 3, you'd be here. That is not on the y-axis, right? So it is not a y-intercept. So you can't just plug 3 into b and be done. You can't do this. You're not allowed to just say y equals 1x plus 3. Done, right? That is not allowed because 3 is dedicated, like this number here is supposed to be the y-intercept, and this is not the y-intercept, okay? So instead what we have to do is use this point and this equation to find the y-intercept. And this revolves around the old fundamental idea of algebra, and that's that one variable equations can be solved for the one missing variable. So if you've got y equals mx plus b, we know an x and a y value that go together. So 5, 3 goes together. So if we plug 5 into x and 3 into y, and m, or 1, into m, then we can solve for the missing variable. So plug these two things in simultaneously into y and x. This is y and this is x. It'd be 3 equals your m, which is 1, times your x, which is 5, plus b. And now you solve this equation for b. So you get 3 equals 5 plus b. Subtract 5 from both sides, and you get negative 2 equals b. And now that you know m and b, all right, we know these two things now, that allows us to plug it into this format. Y equals mx plus b, where you substitute m and you substitute b. So our final answer is y equals 1x, because that's what m is, minus 2. Okay? Moving on to a separate instance, a separate situation for finding equations of lines. In this problem, you're given 2 points that the line passes through. So they've identified 2 points on the line, and now you have to make an equation that can generate every other point on the line. And I want to relate this to the previous problem. On the previous problem, we used two things. We used a slope and a point, and we plugged it in and could find the formula. So things we knew, slope and a point. So I'm going to write that down. Things to know to finish problem. Slope and a point. Right now we know at least 1 point. We know 2 points, and that's fine, right? Just pick one of them. I'm going to pick this one here. So I know a point. What I don't know is the slope. And you can find the slope by using the slope formula, just like we did towards the beginning of this lesson. It's when you have two ordered pairs with an x and a y and an x and a y, it's the difference in the y's over the difference in the x's. Oh man, I'm not feeling good at all. So you're going to have negative 8 over negative 2, which is 4. Jeez. um, sorry, I'm losing my train of thought because I'm feeling sick. Right, so now we know slope. So the slope is 4. And now that we know the slope and a point, you can plug those into y equals mx plus b, where 4 goes into m and this x and this y goes into x and y. And so plugging this into x, this into y, and this into m, and you're going to get negative 1 equals 4 times 10 plus b, and solve. And now rewrite your equation. And there you have it. Moving on to the second to last thing we're doing today, which is finding x and y intercepts. And I will give a brief summary as to why we do this to find an x or a y intercept. To find an x-intercept, and actually I'll also talk about standard form, which is another type of form that equations can be in of lines. To find x-intercepts whenever you're given standard form, or any line actually, any equation of a line actually, if you plug 0 in for y and solve for the x, you will get the x value of the x-intercept. And the reason for that is because x-intercepts are places on a line that touch the x-axis. Not necessarily cross, but touch. So if you think about any ordered pair that touches the x-axis, so here is the x-axis. Any ordered pair that lies on the x-axis, whether that be negative 10, 0, 0, 0, 9, 0, you name it. They all have one thing in common, and that is that their y value of the ordered pair is 0. Right? That's important. X-intercepts will always have a y value of 0 as their ordered pair. We're going to use that to our advantage. Since we know that all x-intercepts have y values of 0, that is why you plug 0 in for y. We know that the y has to be 0 for it to be an x-intercept. So you plug in 0 for y and then solve, and it will find the x value that will give you the x-intercept. Simple as that. It'll find the place on that line where the y value is 0, which can only be the x-intercept. And the reverse is true for the y-intercept. All y-intercepts, and again, y-intercepts are places on your graph that touch the y-axis. Here's the y-axis. All points on the y-axis have one thing in common, and that is that the ordered pairs associated with them always have x values of 0. This is 0, 9. This is 0, 7. This is 0, negative, like 7-ish. And I know these green is not very good to see, but the idea is that the x value will be 0. So on all the y-intercepts, you plug in 0 for x and solve for y, because you have to in order to get a y-intercept. So let's go ahead and try these. And something I want to point out, this is standard form. Okay, standard form is ax plus by equals c, where your x and your y are together and it equals one number. Okay, that is standard form. Anyway, that aside, to find the x-intercept, you plug in 0 for y and solve for x. To find the y-intercept, you plug in 0 for x and solve for y. Solving these, you'd get 2x equals 9, and so x equals 9 over 2. Here you get 3y equals 9, and so y equals 3. And this is the x value of the x-intercept, and this is the y value of the y-intercept. So remember, all x-intercepts have y values of 0. You plugged in 0. So the actual intercept is 9/2 comma 0. And then on the y-intercept, you plugged in 0 for x. So you get 0 for x, comma 3. Those are your intercepts. Now, to find the x and y-intercepts of a line and slope intercept form, you do the same thing. To find the x-intercept, you plug in 0 for y and solve for x. Why did I do that? I didn't make any progress. Subtract 5 and now multiply by 2, or divide by 1/2. So x is -10 there. And then something I want to point out here. We know that this is in slope-intercept form. Therefore, this value is b, and that is your y-intercept. But we're going to show that in a different way. We're going to do this method where you plug in 0 for x and solve for y and see what we get. So just to prove, or to further show, it doesn't really prove, but to further show that this is a way to find the y-intercept. Plug in 0 for x and solve for y. So you get y equals 5 because 0 times 1/2 is 0. And that's exactly what we would have gotten. So your intercepts, -10 comma 0 and 0 comma 5. And finally, the last thing we'll be doing is looking at how to graph a line in standard form. You absolutely could convert this to slope-intercept form, okay? You absolutely could. Now, I'm going to erase all this. But you absolutely could do this. Add 3x to both sides, you get 2y equals 3x plus 6. Divide by 2, and get y equals 3/2 x plus 3. And then that's your y-intercept and that's your slope. However, I'm going to write that down over here. However, what I'm going to do is not that. I'm going to find x and y intercepts using the method we were just doing, where you plug in 0 for x and plug in 0 for y. And I will see if I get the same thing. So, x-intercept, you plug in 0 for y, and solve for x. And so you get -2 comma 0. And the y-intercept, I really like this blue color. You plug in 0 for x and solve for y. And look, we got the same y-intercept. Now we're going to plot these 2 points. That's what you do next. You first find the intercepts, and then you plot the intercepts, and then you connect the dots. So -2, 0 is right here, and 0, 3 is right here. And you connect the dots. And let's see if this is true right here. Is the connection between here and here 3 over 2? So if you go from here, you go up 3, 1, 2, 3 over 2. Look at that. Same exact line. All right, hopefully you found this helpful. If you have any questions, please let me know. Please work on your homework as much as you can in class and ask me any questions you have. All right, I'm here to help. All right, don't be lazy. Do your homework and turn it in.